Hello, this is Mr. Gilmore with the 2.2 Related Conditionals lesson. In 2.1, we introduced what a conditional is. However, there are different forms a conditional can take. These forms are going to include the converse, the inverse, and the contrapositive. Let's take a look at how we are going to transform the original conditional into its related conditionals, again known as the converse, the inverse, and the contrapositive. Now, in our original conditional, we had if given, then conclusion. Let's simplify that down to if G, then C. Well, then we can transform that statement into its related conditionals. Let's take a look at what the converse is. The converse is the exchange of the given and conclusion, meaning we take the given and the conclusion and we swap places with it. So the converse is if C, then G. Now, the inverse is where we're going to find our new word called negation. A negation means simply to make it the opposite of what it is. So if I were to say the pizza is cold, to negate that statement, I would say the pizza is not cold. In our case, with the inverse, I would say if not G, then not C. So simply, I'm negating the given and conclusion. Notice that I do not exchange them. The converse is where I exchange. The inverse is where I negate. The last one is known as the contrapositive. The contrapositive is where we do both the exchange and the negation. So I would read that statement as if not C, then not G. And this is, of course, transforming the original conditional. And that's where we begin with each of the new related ones, is we go back to the original conditional and transform that one. Let's take a look at an example. Here's the original conditional in the middle. If a polygon is regular, then it has equal sides. Well, let's transform that into a converse, inverse, and contrapositive. And then we're going to answer the truth value, which means this statement will either be true or false. And we'll do that for each of the related conditionals. Let's start by actually stating what this truth value of the original conditional is. So if a polygon is regular, meaning it's equilateral and equiangular, meaning it has all equal sides and all equal angles, then it has equal sides. Well, that is true. Okay, because it already is established as regular, that means it does have equal sides. Now, you'll note that these slides have one additional slide in this rather than what the PowerPoint slides is because I don't have enough room to transform the converse, inverse, contrapositive on this slide, so I've included another slide where I have transformed them. Let's take a look at the converse, inverse, and contrapositive. The converse of the statement, remember, is the exchange of the given and conclusion. So the given of the original was that the polygon was regular, and the conclusion was that it has equal sides. Let's exchange them. So now the converse reads, if a polygon has equal sides, then it is regular. That is false. So if a polygon has equal sides, I think of a rhombus. A rhombus has equal sides. Is it regular then? Not necessarily. We do not know that the interior angles are all equal. In order to be regular, it has to be both equilateral and equiangular. Let's take a look at the inverse. Inverse is the negation of the original conditional. So the original conditional, remember, is a polygon is regular, then it has equal sides. Let's negate that. If a polygon is not regular, then it does not have equal sides. That is also false. So a polygon may not be regular, that's true, but it could have equal sides. Again, think of a rhombus. A rhombus is not regular, but it does have equal sides. Thus, that statement is false. Let's look at the contrapositive. The contrapositive is the exchange and the negation of the original conditional. Again, the original conditional, if a polygon is regular then has equal sides, let's negate and exchange. So if a polygon does not have equal sides, then it is not regular. That's true, right? If a polygon doesn't have equal sides, then it cannot be regular, because the regular definition requires that it does have at least all equal sides, plus all equal angles. Now, hopefully you saw there were two observations that we can make, and then there will be a consequence of these two observations. The first observation is this: a conditional statement and its converse can have different truth values, right? Just because the conditional is true, it does not guarantee that the converse is true. There will be statements in which they are both true. There will be statements in which they're both false. But just because we know the truth value of one, it does not guarantee or dictate the truth value of the other. Here's an example, okay? This is actually an example of a conditional statement in which the conditional is true, and what we'll have to find later is that the converse is also true. If a triangle is right, then the sum of the squares of its legs equals the square of its hypotenuse. That's known as the Pythagorean theorem. It's true. And the converse of this is true, but it's not guaranteed to be true because the conditional is true. We have to actually prove the converse true as well, which means when we reach this point in time where we prove the Pythagorean theorem, we will also in turn prove the converse of the Pythagorean theorem. The second observation I wanted you to make is that we did end up producing a related conditional that did have the same truth value as the conditional, and that was the contrapositive. As it turns out, the conditional and the contrapositive are equivalent statements. Even though they're written differently, they really do mean the same thing. And that means they will always have the same truth value. So either both will be true or both will be false. You'll never have a mixed match form of a conditional and its contrapositive. The conditional and contrapositive will always have the same truth value. Here's a quick example of that. If an animal is a vertebrate, then it has a nervous system. Okay, that is true. If it's vertebrate, it means it has a spine, which means it does have a nervous system. If I were to write the contrapositive of that, if an animal does not have a nervous system, then it is not a vertebrate. Then that is also true. It's actually an equivalent way of rewriting this sentence. So the conditional and the contrapositive again will always have the same truth value. Now, a consequence of this. What about the converse and inverse? Is there a relationship there? Yes, there is. As it turns out, if you compare the converse to the inverse is the contrapositive of the converse. Think about how you form the contrapositive from the original conditional. You negate and exchange. Well, observe what's happening to go from the converse to the inverse. It is a negation and an exchange, which means the converse and inverse they are equivalent statements as well, which means they will also have the same truth values for both of them. So if the converse is true, the inverse is true. You'll never have a mixed match form of the converse and inverse truth values. With that, that ends our 2.2 lesson on related conditionals. Be sure to check out the worksheet for more information. If you do have any questions, do not hesitate to email me. And with that, be good and do good.